Today's seminar will be on the topic that will IoT-based solutions succeed in removing the energy guzzler tag from HVAC? And we have our esteemed panelist, Mr. Prabhat Goyal, who will be taking you guys through his experience working in the HVAC industry. But before we get started, a few housekeeping items. While it's a 1 hour long seminar, we will be limiting our discussion from the panelist side to 45 minutes. And then we'll open up the session for a 15-minute Q&A. I would request that everybody should post their questions in the Q&A section and not in the chat section. We will only be following all the questions that are posted in the Q&A part of the seminar. We will be happy to share the slides and the webinar recording and email it to everyone after the session. You will also receive a short survey immediately at the end of the seminar. We would surely love to hear your feedback. And while we go through the slides, we will have a couple of polls. I request that we would be opening up the poll for a short time, let's say 30 odd seconds. So as soon as we open up the poll and we let all the attendees know, I would request that you guys just participate in the poll, and we'll then post the poll response to everyone as well. Yeah, it's my pleasure to have Mr. Prabhat with us taking this seminar. I have myself enjoyed all my conversations with him. Every time I speak with him, I get to learn 10 new things that he sort of brings along from his vast 40 years of experience in the HVAC industry. He has been a pioneer in adopting the automation systems when perhaps many of us were either still in our primary schools, right, or haven't even heard of the word automation. He, of course, comes from a pretty strong educational pedigree, and so his educational pedigree along with lots of field experience is what makes him quite distinct in the HVAC industry. When I look around, right, you don't find too many people who have similar experience as Mr. Prabhat. So it is a great honor, sir, to have you here in our panel, and I'd just like to pass it on to you to sort of start the discussion, and for which all the attendees have joined today.
Thank you, Amarjeet. Thank you for the fine introduction. I must say I'm still learning today. And one of the reasons why I came along with you guys is I didn't want to stop learning. There's a very famous line by a singer called Bob Dylan who says that when you stop learning, you start dying. You know, if you stop being born, then you start dying. So I think I learned as much as from my participants and you guys as I pass on the information that I have gathered over the years to everyone. I can see about 67 participants who have joined till now, and I'm sure more will be coming in as we proceed. So let me begin and first say what we'll be covering today. So today we will start with talking about HVAC's impact on global warming. I'm going to say the market perceives it in a certain way, and I have carried just one slide for that purpose. Then we will talk about what is the electricity demand, generation, and consumption. These are some statistical slides, basically from International Energy Association and other people. And then we come to the cooling energy demand in India and show you a trend as to where it is going and how it is growing And it has certainly it's a cause of concern. And we need to put in the strategies to contain the energy use. So that is what we will be talking about. And thereafter, we will go into the technologies that are coming in today in order to help us with the strategies to contain the energy use. And one of them, as you know, is IoT-based systems, and it has certain distinct advantages. So we will talk about that. And it will be up to you to decide whether IoT can and has succeeded so far in removing energy guzzler tag from HVAC. 2 years back, when I did my first or the second presentation on IoT in Kolkata, my favorite city, I used this particular term, energy guzzler. We need to remove the energy guzzler tag from heating, ventilation, and air conditioning. And in the last seminar of this series, Rahul also mentioned this particular word, the energy guzzler. And we thought that it just might be appropriate to do this webinar on a topic and throw it to the audience for them to decide if we have a technology today, or we are starting with a technology today which has the potential to remove this particular tag. This will be followed by a question answer session, as Amarjeet said. So feel free to send your questions across on the chat box, and we will try and take it at the end of the seminar. We are very particular about finishing at a particular time so that we allow you a lot of time for the Q&A session. So with these few words, let me get started. And as I said, we will talk about the HVAC's impact on the environment and the global warming. I think pictures speak more than words. You can see that the ice cap is melting. We heard a lot about the impact of global warming this summer. Things in Canada, fires in Turkey, and what have you. So that sort of explains it. India is a part of the Paris Agreement, and we are committed to not allow the global temperature to rise beyond 2 degrees centigrade. And you can see the increase in average which is taking place, and it is resulting in extreme warm weathers. And at the same time, we are seeing a proliferation almost of room ACs and split ACs. They are going all over the place. And we need to sort of take care of the energy that gets used in all these things. Mind you, these little split units, they throw all the warm air outside. So if you were walking in that passage in between the two buildings, you would get the impact of all the hot air that was being thrown out from inside. So energy is neither created nor destroyed. All we do is transfer the energy from inside our rooms to outside. And that, in order to do that, we sort of add what you call energy to it. That's the principles from thermodynamics. And this is what consumes a lot of energy in HVAC systems. So let's go on to the next slide and see what the International Energy Agency or the world is talking about the energy demand caused by HVAC systems in a building. And what they have to say, and what most people have to say, is that air conditioning is the biggest factor in growing electricity demand. The economy of the world is growing. The use of air conditioners is becoming more common, and it is ending up in air conditioning being the biggest factor in the growing electricity demand. 37% of all the electricity that is consumed by the buildings basically goes into the space cooling demand globally. India, it may be a little lesser at this point of time, but be rest assured that it is climbing. A few of the slides now from energy economists. These are third-party slides, and I've just taken them in order to show you what the severity of the situation is like. And why is it that we are getting concerned about the impact of HVAC on the environment or the global warming, and why are we looking for solutions, and what are the solutions that we are looking for basically to enter and curtail this particular growth. So here are some of the slides. This one talks about the global energy consumptions in terawatt hour per year. And what is important in this slide is the bottom one in black, which is generated by coal. So you can see up to 2030, it will sort of steady out, and the generation by coal will reduce and solar will increase, but the overall energy consumption in the globe will go on increasing. Again, the use of coal, oil, and other things, renewables, are brought out in this particular slide. This slide tells you a similar story, and it talks about the electricity generation from non-renewables, which is on top, followed by hydropower and followed by wind power. So you can see the wind power and hydropower, which grew substantially from 2008 to 2018, but it's no match on the non-renewables that we create. And we need to bring down that part of the graph. Once again, the global air conditioner stock, 2018 or 2020, India and China and all look sort of decent, but going ahead, the way we are importing 3 million units a year and producing almost a similar amount, you know, the stock is going to go up and up and up, and we need to take care of the energy that is consumed by these. One thing that still remains is coal power final investment decisions. And as you can see in China and India, even till later, for a few years from now, we will still be sort of planning out and rolling out coal-based power plants, which is pretty detrimental. And that is one of the major reasons why energy saving has become a big thing. And IoT is, according to me, is going to be a technology which is going to be the biggest contributor in allowing us to contain it. This is a great chart or a graph basically put up by AEEE in India. I must give them the credit for this. It comes out of a study which they have published as India Cooling Action Plan, and it talks about the cooling energy demand of India, and which they say will double till 2027. And there are two terms used over here, BAU and improve. BAU basically means business as usual. If we did nothing, the taller graph is where we will reach. But if we improve things then and contain it, then we have a much better chance of keeping this under wraps and not increasing the energy consumption, which will further lead to global warming and things like that. So here is the breakdown that they have given. And this is a very, very important graph, which they have produced, full marks to them. They have broken down the cooling or space cooling in buildings energy consumption into the various things that we use, starting from room air conditioners, our very favorite chiller systems. I'm sure a lot of you who have joined today basically come from the chiller stock, the VRF systems, which are becoming very popular, the packaged DX units, which we keep on top of the roofs, and we have our fans, we have our air coolers, and they have also given the total at the end of it. And they are basically talking about 2017, 2027, business as usual, and 2027 improved in the dark blue line So you can see how much reduction we can cause. And this graph also tells you one more very important thing, and that is basically that we need to look into the RAC segment of the business, or the split unit segment of the business, or the small segment of the business, the one which goes into our retail, which goes into our shop fronts, and many of the banks, and which are not really chill water systems. So we can't just get away by doing a lot of things for the chiller systems and ignoring the RAC systems. And to the end of my presentation, what you will find is that IoT is going to play, Internet of Things is going to play a very important role in this RAC segment also, because really the building management systems and other things are designed for the chiller system, and they don't contribute much to the RAC systems. So at this stage, I will pass it back to my friend, Mr. Amarjeet, and he will run a small poll for you to reply, and please reply that, and that gives us an indication as to where our energy is being used in the buildings. So over to you, Amarjeet.
Yeah, the poll has started. We'll wait for another 30 seconds
Very
to
good.
let the participants answer.
So I think
We can
the
end the
answer
poll.
is yes, we can end the poll. The answer is very clear. 97% of the people understand, and many other places where this poll has been done, the answers are very similar, that space cooling in buildings takes away most of the uh, the energy that gets into our buildings. So let me get ahead and go to the next slide. Okay. So if the HVAC systems are consuming such a lot of the energy that is getting into our buildings, we need some strategies to contain this particular energy use. And I have listed down some of them over here. The first one is more efficient HVAC equipment. The HVAC equipment industry, the manufacturers are doing their utmost to increase the efficiency of the equipment that they build, may it be chillers, may it be package units. We have the great, the star rating system introduced by BWE. The whole idea is to make the air conditioners, to challenge the manufacturers to make the air conditioners more and more efficient every year. That's why they raise the COP number, or they lower the kilowatt per ton from year to year to qualify for a 5-star rating. And a number of manufacturers are building in embedded systems within the electronics that they put into the machines in order to save energy. And these are very compatible with the IoT-based monitoring and energy control systems. They sort of match up 1:1 by taking on board BACnet, Modbus, and many other protocols by which they become very easy for the IoT-based systems to go and interact with them. The answer being that you really, after that, do not need to add too many sensors to these HVAC equipment in order to be able to collect data from them, analyze them, and make them more energy efficient. The second important thing is more emphasis on efficient HVAC system design. A lot of us are into energy simulation, and the new thing that has come in is energy performance standards. So we are not only talking about design standards, but we are also talking about performance standards. And you will see papers where people have gone and done measurements on large buildings, and they find that from the energy that we predict in terms of design standards, due to many a reason like changing occupancy, changing other parameters, a good weather profile, a bad weather profile, the ultimate energy spend changes, and this is also predictable. But fact remains that we need to measure our energy spend if we need to go ahead and take advantage of this. And that is one thing which IoT-based systems have to offer in this particular sphere. The third important thing is proper commissioning of HVAC systems. And that basically means maintaining our commissioning data. If we don't maintain our commissioning data, a lot of the times today, when retrofit has become so important, we really struggle to go back and find what were we doing when the building has started shop. And a lot of you who are in the HVAC chiller plant or large building area, you have faced the problem that when we install very large building monitoring systems, which do help us at the end of the day, they are not ready by the time we go in for commissioning. They come in and get ready only after the commissioning has taken place. And we are unable to either use the system to record the commissioning data. And what I feel is going ahead, even the various commissioning meetings that we have, people are demanding that one way or the other, we should be making a note of all the commissioning readings that we record during the process. And the design engineers should be able to look at sitting in their offices as to what is happening during commissioning time. How close are they to what they had forecast? Okay, the next one is monitoring energy consumption and maintaining energy efficiency levels, and then benchmarking the buildings. So this is where really IoT-based systems score 100 on 100, or you can say 95 on 100 as on date, basically. We need to, whatever equipment we put into our buildings, we need to maintain it, and we need to maintain their energy efficiency. And things like coefficient of performance and other things I will come to in a slide. We need to have a regular look at that and maintain a data. And in today's time and date, we need systems that will throw up things at us in case they are not being maintained due to various reasons. And I will come to those particular reasons in one of my slides later. Last but not least, this is something pretty original, I would say, and this is influencing user behavior by giving greater visibility of energy used by making energy use data visible and readily available. Now, look at what happened to the world a few years back when one of the first IoT-based devices appeared in the market. It was a small wristband. Basically, whenever you went jogging or whenever you went walking, a lot of the people wore it. And when they came back to their desks, the connected system was able to pick up the data of how much walking or jogging or exercising they had done in calories and things like that. And the data was visible to them that this is what you did last month, this is what you did this month. And that sort of had a great impact on the world. The data being visible, now people were sort of able to compare things with each other, father with their daughters, husbands with their wives, and you were now talking specific numbers that I did this much walking today. Imagine if the RACs and the split units get equipped with just little bit more hardware, and it throws up to you as to how much energy you have consumed using your room air conditioner or your split unit in your office. A lot of us will be inclined towards uh, targeting a certain figure, challenging ourselves and keeping it down, knowing fully well that all these systems at the end of the day are sort of causing the polar ice to melt. You can't get that image of the polar bear, not being able to go from one place to the other because his path has melted, and we will take care. So if we have to influence user behavior for mass equipment, then I think pushing up the energy data and making it more visible will certainly help in time to come. Okay, let's get on to my next slide. And these are basically just data collected on more efficient HVAC equipment. The equipment is now being certified by certain agencies, and self-certification is not the end of the day. I'm to say, you saw what happened in the car industry doing self-certification. So things are tested, or samples are tested, and then EER and COPs are published, and people are basically encouraged to use these certified equipment or equipment with certified energy data, and that's becoming more popular. There are newer systems. Today, the world is talking about compressor-less cooling, and you're talking about evaporative cooling systems. And in order to make them work based on what is the present humidity level, and if the humidity level is low, then we should be using evaporative cooling at that point of time, and we should bring in the compressor only when the humidity levels get higher, and that too the minimum usage of compressor. It needs advanced controls. And the smaller items normally get devoid of large DDC-based controllers and large systems. They have to go more towards edge-based controllers and wireless sensors, and systems that can easily be tracked using probably the home automation systems kind of thing, which today even Google and Amazon and Apple have landed up with chip technology and things like that, where they are saying that it's a connected home and on IT systems. So these kind of systems can benefit a lot. And if you are a manufacturer today of these kind of systems, come ahead and talk to people about integrating small things onto your systems so that they become interactive and they can participate in this IoT revolution going ahead. Indirect evaporative cooling, again, can benefit heavily from IoT-based systems. And now let's get into some of the other strategies. And we have on board more emphasis on efficient HVAC system design. So equipment design and system design, as we all know, are two separate things. We do energy simulation, we get into energy performance standards, and we get into commissioning. I have already talked a lot about it. And again, to keep these efficient systems working seamlessly, we need our investments into wireless sensors, IoT-based systems, or what have you. I have put up this picture over here because this was, amongst all my research, a system that claimed the lowest kilowatt hour usage per square meter per year. And this is being done in India. And it makes a substantial reduction in the amount of energy that it will consume as compared to our normal HVAC system. But to keep it going zone by zone, putting the right amount of cold water into these particular pipes requires sensors at times to be moved from one place to the other. And you will need wireless sensors to do that, and IoT may be your best solution in this particular case. Now, let us talk about continuous verification or verification as such. And this is where we need to really have a quantum jump. I'm to say today, commissioning data, unfortunately, is still kind of handwritten in pieces of paper or in registers. And really, that data is not something which is going to be available when you are going in for renovation after such a long time. And we need a quantum jump in that. As we commission an air handling unit, or as we commission a chiller, all this data needs to be stored as to what it was during the commissioning time. And that is a quantum jump which IoT-based systems promise to provide us. And once we have this data available with us, a lot of things open up to us, and I'm going to come to it in my subsequent slides. So, monitoring energy consumption and maintaining energy efficiency levels and benchmarking is going to be the key. And let's go ahead and have a look at that. Things today, amongst the technologies that have come into air conditioning, the compressors, heat exchangers, and what have you, have all improved. And one of the things that has come in is connectivity. And once we have systems which have connectivity and are talking to the cloud or to any kind of storage system, whether in your building, outside the building, and are able to store the data, a lot of opportunities open up. And that's where it is. There are things, these are compressors, these are fans, these are motors, and they have an identity, and they are now connected to a database, and they transfer their data, and suddenly you have a very strong system by which you can collect the data, you can analyze the data. So 4 pillars of the IoT-based systems, which offer you some distinct advantages over whatever we have till today, is that we need a solution which is light and software intelligent solution. You know, going and laying miles and miles of conduiting, yes, we did it when it was required. But today, if the world is giving you a better technology, then you don't really take a 16-pin connector and connect your laptop to a television screen or something like that. You use today's technology, it comes built in, you want to press a couple of keys and bang, the picture comes onto the television screen. So similarly, a lot of manufacturers are putting in stuff which makes these kind of data systems or things that transfer the data from the equipment onto the database much, much lighter and software based. Again, for years together, we struggled on protocols. You know, we did integration. We made question and answer sessions between 2 kinds of systems, and we kept seeing the blinking lights and things like that. Today, if time permits, I will show you a video where in International Institute of Information Technology, the 20 and 21 and 22-year-olds are getting into any particular system that is willing to talk to them, or they make the systems talk to them and are collecting data and are writing apps, as they call software solutions, to make them work better. That's the world today. So we need systems which are OEM and machine agnostic. Wireless technology, we have all come to basically, we are today using a lot of wireless things, starting from your mouse, starting from the little band you wear on your hands, transferring data onto television screens. And today the sensors, and we're talking about, cars, automobiles, which will run by itself and take data how far they are from the next vehicle. And in that time, if we start sticking to things where we need conduiting and cabling to be done in thousands of miles within a building, I think we are not really using the technology. And in order to support that, initially came the Bluetooth and the Wi-Fi, but today a lot many protocols are being introduced, and very effectively so by large corporations, medium-sized corporations, and they are making those wireless products more and more reliable. And at the same time, they are bringing the costs down and they are bringing it into the hands of the consumers. The last part of this particular 4 pillars is the analytics power. I would say we have most of us have, set up building management systems in buildings or have interacted with equipments like chillers, air handling units, and what have you. But at the end of the day, while we could look at the things and we could also collect history, it was not really very easy to take all this historical data and put it in a hard disk. Either the hard disks were too small or it was not happening. And as a result, today, when we go back to these last 20, 25 years of such great buildings and we try to extract data out of that, we are not very this thing in doing that. We face a lot of problems with that. And today, the system which has arrived, the IoT-based system, Internet of Things-based system which has arrived, basically collects a lot more data. And thanks to our capability of storing data becoming so much easier and cheaper, we are able to store a lot of data. And the best part is that we are able to analyze. Now we have a big database and the data is available for analysis. So when you analyze the data, it gives you a lot of clues, and we will talk about it in the upcoming slides. So before I go into that, let me just tell you that the advantage that we gain, the unique advantage that we gain on the IoT platform is that now we can put small buildings, retail as easily as we were putting large commercial buildings. BMS systems are not developed for small buildings retail, so IoT systems go in much easier over there. The energy wastage due to manual control can be avoided in small buildings as effectively, and you can automate it or leave it to IoT-based systems providers to provide the right amount of energy use and automation and bring down your energy bill. At the end of the day, that is what you are looking at. You are not only bringing down your bill, which should be one of the things that takes you to do that, but you're also saving the environment in the process of doing that. Large commercial buildings, if you have planned or if you already have a BMS, these kind of systems sit seamlessly on that. So here was a slide of some of the first few things like the thermostat, which talked to the net and got the weather and managed to change its set points within the 24 hours also and save energy. Here is a slide which is showing you how from window air conditioners, we can pick up the data with minimum add of hardware. Really, it's not going to add an arm and a leg to the cost of the air conditioner, but it's going to provide you the data not only of the current kilowatt usage, but the kilowatt hours that you have consumed probably over a period of a month, and is going to help a lot in changing user behavior. Similarly, on split units, we all faced recently the problem when fresh air was not provided in the system, and fresh air is now going to get added. There is a huge requirement, and monitoring indoor air quality is going to pose a huge requirement in these particular things, especially in hospitals, hotels, public areas, where people are going to be very careful about where they enter. And IoT-based indoor air quality monitoring is going to start off in a big way. And these are small systems, again, going on IoT-based systems rather than on the larger systems. So here is a very unique and important slide of mine, which I'll speak to. I'm almost coming to the end of my presentation. And this is what IoT systems are going to do in future for our chill water systems, for the chillers. And a lot of you who are participating today are from this particular field. So here is what the take is: the continuous monitoring of chillers, COP. That means we are basically looking at the flow through the chiller. We are looking at the delta T inlet and outlet, and we are looking at the power consumption of the chiller. And if we form a database of these particular things, there are a lot of research going on today, and these things are definite to hit the market today, tomorrow, near future, is that you will be able to predict when a chiller is short of refrigerant charge and it's still operating, because it really brings down the efficiency of the chiller. Similarly, if oil accumulates in the cooler, it's one of the toughest things to investigate. Basically, all that happens is your chiller COP goes down, and probably a lot of the other parameters remain the same. And this is when you have to go pull the oil back from the cooler into the compressor by putting it on full load or something like that. And if you have a large database and analyze it, there is a possibility that you will reach to this conclusion and be able to trigger the solenoid that allows the oil to be taken out by actions back into compressor. The third thing that it promises is extensive part load operation elimination or reduction. We all know when our chillers go on part load and they keep operating on part load, our coefficient of performance or efficiency of performance is not good. And if we see a graph drawn out of the chiller operational data, and we see extensive part load operation, it is the same point at which your COPs or your efficiency of the chiller is not proper. And we really don't end up drawing those graphs today with whatever data we collect. But in time to come, IoT will assist us in doing that. It will also assist us in letting us know when the descaling of condensers should take place. This is one thing which I think a lot of you are today using the present systems in order to be able to forecast as to when to descale a condenser. And continuous monitoring of energy data will almost become an inbuilt thing in our system. So at this point of time, for these 5 important things that the chillers, people coming from the chiller background face, we have a little poll, and I will ask Amarjeet to run that poll, and you need to say which one affects you the most. So here it goes.
While the poll is going on, I see that a few people have raised their hands. As mentioned in the beginning, please put your questions in the Q&A session and we'll address all those questions together in the end. And please don't add these questions in the chat session. And Mr. Prabhat, perhaps in the next 3 to 5 minutes, we should try to wrap up so that we have then time for.
I'm coming to an end.
Yeah.
I'm coming to an end.
I'll finish the poll and then we can continue.
Yes. Right. I think we have stabilized now, and extensive part load operation is showing up to be the biggest concern that people have. And almost 50% of the people are saying that extensive part load operation is where they face the problem. And I'm happy to see that oil accumulation in coolers is also scoring 20%. It's one of the most difficult things to diagnose. And till now, the systems have not really helped us in diagnosing that. In future, our only hope remains if we have enough data to be able to do that. So Amarjeet, if you can stop the poll, then I can move ahead and you can share the results. So here are the results. They come up on your screen, and I'm closing this screen and I'm going ahead and trying to finish ASAP now. Okay, so these are the screens where people have already put in IoT-based systems. I think we need to look at things because my monitor is saying that things are not going ahead. If you can please close it, close the poll. The results of the poll are still showing on, yeah, okay, fair enough. So now pump manufacturers have put in their things, valve actuators have put in their things, damper actuators, and all this data will be freely available to you to read in time to come using IoT-based systems. Chiller manufacturers are adding, intelligence and passing data onto the screen, and I will show you how an open protocol IoT system will be able to access most of this data as long as people give permissions and allow the IoT architecture-based systems to interact with them. So on your screen, you see basically 3 different kinds of gateways. And the first one takes sensors directly, takes Wi-Fi connected equipment directly. The second one is taking the Wi-Fi connected equipment and what is called the open thread. And this is where we were talking about some of the largest corporations coming in and putting in interactive systems which have a great possibility of utilizing low amount of power. So you won't have to have connected power supply to these particular things. And they will be talking seamlessly to the cloud or directly from the cloud, which may be located internally or externally in buildings, and talking to your systems. Last but not least, if you already have a BMS system and they have things like BACnet or Modbus, which we are used to as HVAC people, they will talk directly to these particular systems. Very simple gateways required for that, and you'll be able to take the data offshore. So future holds some promise with the IoT architecture, and it's not only going to be, you will see a lot of medium-sized companies getting onto the scene and possibly helping you out with this particular technology. So here are 2 screens for comparing the different kinds of wireless connectivity and the open thread system, which is widely being adopted by even people like Google, Amazon, and Apple are well supported today and possibly may take a lead in time to come. So coming to some of my concluding slides now, I'm very close to my time. So what we need to do is we need to better manage energy. We need to lead from the front when it comes to using information-based technologies. India is a great country for information-based technologies. And doing these particular things, we should all work together in shedding the tag that air conditioning is an energy guzzler. It will only become possible if all of us put our best foot forward and support it in order to make things happen. Now, we had done a poll in the last webinar also, and again, high energy cost had come as the biggest killer. And people like IEA in their reports are also saying that digital tools and sensors are key to enabling the transformation of urban energy systems to reach the zero net energy goals. We are all aspiring towards it. And here is a slide of college in Hyderabad. where youngsters are getting into the very basics of this. And my message to you this time is, let's develop our own systems this time. We are not just going to be dependent on the world to provide us systems and we be the users. This is one particular area where a lot of fundamental research and a lot of work is being done by the youngsters. And as HVAC people, we should be going all out to encourage them. And wherever you see even a small thing being proposed by them, be ready to take it on board. And that is how we will move forward, and we will keep pace with the world on these IoT systems. A lot of the companies have already taken it on board, and this includes hotels and buildings, F&B, supermarkets, retail chains, and stores, what have you. And the slide tells the story as to who are the forward-looking people. Similarly, most companies will show you that a lot of people have come forward and they're already gaining advantage and have managed to reduce their energy bills using this technology. Last but not least, I think in time to come, the power measurement should become mandatory. A lot of the energy performance standards are coming out, and with the help of a lot of people, we should at least make measuring power kind of mandatory for buildings that we give awards to. And the buildings that we consider are kind of gold, silver, or bronze, in keeping with the many standards that we have developed for them. I will now hand it back to Amarjeet to explain how this thing has evolved and how providers have taken this technology forward. So over to you, Amarjeet.
Sure.
And this will be followed by the Q&A session.
Sure. Thank you, Mr. Prabhat. I think this was very, very enlightening talk. And I think some of the things that you sort of started from, right, really are the things that we also feel concerned about, right? Energy consumption is growing. We are already seeing catastrophic events across the world. Climate change is the reality. And I mean, many of us here in this session also would be perhaps parents, right? And it's our duty to ensure that the future we pass on to our kids is better and not worse than what we inherited from our parents, right? And these are the things that actually keep us at Zenatix also motivated and keep us up at night. As you rightly pointed out, buildings consume roughly about 60% of the global energy consumption, right? And within the buildings, about 20 to 30% of the energy is getting wasted. So essentially, if we have to look at one single direction which can have the biggest dent in terms of sustainable future, it's perhaps the building energy consumption. And as you pointed out, within the buildings, because HVAC is the biggest guzzler, so if we can optimize the HVAC energy consumption within the buildings, that's where perhaps we can create the biggest dent towards the sustainable future. And I think your last few points rightly touched upon the nerve, right? That so in buildings, so if you look at the statistics, right, less than 5% of the buildings in India have BMS, and compare that to a country like the US, where more than 50% of the buildings have BMS, right? And largely the reason is that these systems were built for a very different environment, with a very different context. And perhaps many of us here who have either put in a BMS in their building or have been part of the BMS commissioning would understand this pain point that, I mean, often 99% of these BMS don't even work a few years down the road after they have been commissioned, right? Something or the else is broken in that system. So even for the buildings that have an automation system, it doesn't work properly, right? And I think that's where you have rightly pointed out that there is a big global gap, right? And then there is a big India gap also, right? So of course, buildings in India need automation that is built in India and built for India, right? And of course, if we look at small buildings, right, buildings which are less than 100,000 square feet or smaller, right? Even globally, even in the US, less than 2% of those buildings have BMS, right? Because the cost of the BMS doesn't justify the ROI, right? So if you put these two things together, there is a big global gap in the buildings which are 100,000 square feet or smaller. And then when it comes to emerging economies like India, there is a gap in terms of creating a technology which is affordable, which is suited for this kind of an environment, which is built locally and commissioned locally, in a way also surpassing uh, many of the things that traditional BMS has still adopted, right? I mean, if you look at it, perhaps the landline penetration in the US is much more than in India, right? And India has
Yes.
leapfrogged US and created many more mobile connections. So should we be actually adopting the traditional wired BMS, or should we just leapfrog and say that, look, we will actually adopt a wireless IoT technology, right? And perhaps 5-10 years down the road, more number of buildings in India would have that kind of an automation than the wired automation, which is much more expensive, much more difficult to maintain in the US, right? And I think that is where Zenatix comes into picture. We have built tools and technologies over the last 7 years, uh, really, ensuring that it's low cost, it's affordable, and the scale sort of speaks for it, right? We are already in our systems are deployed at across more than 200 cities in India. Uh, the systems give cost efficiency in terms of ROI, which is between 12 to 18 months, something which is unheard of in this industry, right? A BMS project in everyone's head, people think that a BMS takes 4 to 6 months to commission. We are talking about a couple of weeks to commission the whole IoT system, right? Because it's wireless and plug and play, right? So in a way, we are questioning all the traditional things that the BMS ecosystem is still clinging on to, right? And I think that is where the real innovation is, that you can, in this industry which is crying for innovation, you cannot just do incremental changes. You have to think out of the box, do these fundamental changes in the way systems operate, and sort of take it forward. And I mean, as you already mentioned, there are a lot of early adopters uh, in India and globally that have adopted these IoT-based systems. Zenatix is definitely well positioned to serve many of the varied uh, automation requirements across the buildings, whether it is you are controlling the room air conditioning or a ductable air conditioner or a VRV or a VRF or a chiller based system. We have solutions to do automation and control for all types of air conditioning. So I think, I mean, without going any further, because we had promised for a Q&A session and we are already nearing the end of the session, if I can request Mr. Prabhat for you to stay around for another
Yes.
10 minutes. Let's take on the question and answers, and so that, I mean, we can make the whole session more interactive. So I
Right,
think
sir.
initial question comes from Mr. Gaurav. What is this commissioning data and how is it maintained?
Okay. So I've been part of actual commissioning and I've been part of commissioning standards team also. Now, when you are commissioning, I'll start from the chilled water system basically. So you have the chilled water pumps, the condenser water pumps, the cooling tower fans, and everywhere you basically balance it. And once it is balanced, you note down what is the power consumption in the condenser water pumps, the chilled water pumps, the cooling tower fans, etc. in that balanced flow situation. Once you have done that, then you move on to the chiller. So you start your chillers, and that is the time when you make sure that you have the delta T across the chiller. That means if you are working on 5.5 leaving and say 10.5 entering in degrees centigrade, or 45 degrees Fahrenheit, 55 degrees Fahrenheit. You simulated the return water temperature definitely, and you take the chiller up to full load because you have designed it for 8 degrees Fahrenheit or 10 degrees Fahrenheit. Once you have the chiller in operation in the building, you really don't have the luxury to bring up the return water temperature all the time. And that is the time you basically record your full load amps into the compressor. And as it unloads, you basically take what are your amps coming from 100% load to say 60, 70% load till the point you want to operate it. And this data for different ambient temperatures when you are doing commissioning is very important. And once you have this particular data, this becomes like your baseline. You can set up your baseline with that. The same thing applies on the air side. When you balance your air side systems, what is the consumption from your air handling unit fan motor? That becomes your baseline. And all this data is then compared to the operational data. So today in Europe, what is happening is that their main emphasis is on retrofits. Things are going under retrofits. Who is financing the retrofit? Independent companies are financing the retrofit. Where is the money coming from? The money is coming from the fact that whatever was your energy consumption before and what is your energy consumption going to be after the retrofit, there is going to be a saving. And that saving is financing the retrofit. Now, unless you have the data, how do you start this retrofit? And that is the commissioning data. So we are all struggling to pull out old data from the buildings and forming what was it before it went into retrofit. And most of the time we are looking at data which was recorded when the building was started. It is quite difficult to get, but somewhere down the road with the consulting engineers, with the green building companies, you get to put your hands on this data. And that's the commissioning data. And today it is recorded on Excel sheets or on hard disks and things like that. In the past, it was recorded on registers and things like that. And with that, I hope I have answered your question.
If I may add just one more thing, Mr. Prabhat, I think this data is actually quite useful, not just from the perspective of benchmarking the energy savings, but also from the perspective of predictive maintenance, right? So we know that what is the expected behavior of an equipment when it was working or functioning properly, and then as the building is being operated, is the equipment being working properly, or do you need to service the equipment? This data gets useful there also. And at Zenatix, given you mentioned that this data is largely absent, at Zenatix we do something intelligent there to solve this problem of missing commissioning data. What we do is we would put in our systems, but we would not set up the control routes, right? So our systems will then collect the operating data as on date when there is no automation that is put in place, right? We let the building run in that non-automation mode as it was always running for a few days. Use that data now to benchmark and say that, okay, once we set in our automation rules, how much are you saving, right? So of course, if we had this commissioning data, it would have been even better to have a basic benchmark. But then we sort of, this is how we try to circumvent around and say that, okay, we will collect our baseline data.
So I will just add to that. You know, you hear about variable speed drive chillers.
Right.
In variable speed drive chillers, they've been doing machine learning for the last 7-8 years. I would say 2010, they were doing machine learning in the sense that a variable speed drive chiller has to reduce speed only to the extent that it does not start surging. And the way it is programmed in memory is by allowing it to surge at different temperatures at least once. And then it's like a little child. You know, he suffered a problem at a particular point. He knows where the suffering is going to come, and he doesn't go there. So, these are things.
Correct.
These are things which are going to be very, very important in time to come. I think
Sure.
let's go ahead and take some more questions.
Right. Mr. Sam mentioned, I want to know what is the maximum energy we can save. If I can just say that across our projects at Zenatix, we have seen anywhere from 10 to even 30% of energy savings. In our, as Mr. Prabhat was previously saying, right, it all depends on what was the baseline. We have seen some buildings which were being operated very, very poorly, and therefore you can get 30-40% savings also. We have seen some buildings which were already being operated very, very efficiently. But even in those buildings, once you bring in the IoT systems, 10 to 15, 12, 15% savings is still a cakewalk.
Correct.
Do you have anything else to add,
yes.
Mr. Prabhat?
So I will say, what you measure, you save. Even in your house expenses, when you measure what you are spending, then the savings come in. If you don't even measure, and say in the Middle East, we used to talk about that when you pay an energy bill, at least see that your last bill, the final figure, and your this month's bill, the first figure, are matching. Normally when the energy bill comes, you go to the accounts and give the energy bill, and they say, "Jaldi se pay karo. Otherwise, your electricity will get disconnected." That was where we come from. And in time to come, with these large energy bills, everyone is looking at a way to reduce it. Even if you have 20 people on a floor plate of 6,000 square feet and you're paying them huge salaries, and you say that I'm paying them huge salaries, it is still energy and indoor air quality that is important, which needs to be tracked. So let's go ahead with more questions. I hope we have answered.
I think Mr. Mohammed Salil just have a comment that smart thermostats are useful. I think we all agree on that. It's just about how to integrate those smart thermostats into the bigger ecosystem. Then there is a comment that if I control the AC compressor, won't it affect the lifespan of the AC? How many years of lifespan will be reduced? Mr. Prabhat, you want to spend perhaps?
Yeah, I have worked on chillers. Basically, I have been chiller product manager. I have seen chillers in R&D being developed. Compressors are controlled in different particular ways. Part load operation, full load operation. Today in US, one particular branch of ASHRAE 90.1 thinking is that run the compressor full load as long as you need to run it, and then put it in storage and maintain the storage water temperature. So that, they say, enhances the life of the compressor. Running extensive part loads is where we screw up compressors. We are trying to run it much lower than at lower speeds or at lower capacities, unloaded, and that's where the vibration and other things come in. So yes, compressor control can have a bearing on the life of the compressor, but believe me, companies like Tecumseh, Danfoss, and all these 10 or 15 big compressor manufacturers have put in enough work in understanding what is the sweet spot where their compressors should run at. And their people will be able to guide you on their sweet spot.
Then there's a question on quantifying electricity as CO2 saved. I assume there is actually just a straightforward equation that people often use to convert kWh into the tons of CO2 that is getting saved, right?
So,
Mr. Prabhat?
So Amarjeet, if anyone writes to you on that, there is a great Excel sheet. There's a great sheet, which converts directly from kWh to the amount of CO2 saved. And it's on the net, but we will help whosoever has put up this question to get a copy of the sheet in case we get their email ID. Okay?
Sounds good.
I have it readily available, but I'll spend a lot of time opening it up. Yeah.
Okay. Then there is again a comment that room air conditioners definitely require IoT, and will the manufacturers be looking into it? I mean, we all know that there are already a bunch of smart room air conditioners that are out in the market. Perhaps the adoption is very, very low.
I will disagree with you on this, Amarjeet, for once. You know, the smartness that we have brought in, and it came out in the ad, was I will put on your air conditioner. I will change your set point, you know, from a distance. Yes, that is a kind of a gimmick smartness which came in, and gimmicks only work up to a particular point in time. You know, the smartness has to come in the real stuff where people feel that, yes, I am, by installing this, I'm being smart. And believe me, on the handheld, I have not seen my kilowatt hours till now. And so all of us who we can say we are somewhat educated or savvy, we like to see our kilowatt hours. You know, and then we can say, if it is the month of July, I will use 150 kilowatt hours in my room air conditioner. If it is the month of September, October, going into a cooler climate, I will benchmark it against the maximum consumption and I will use less. So that visibility has to come in the window air conditioners. Sure. And the next thing that has to come in is indoor air quality. You know, indoor air quality is not rocket science. And you will see it definitely in the next 1 to 2 years that the prices, the costs will come down. People will be more inclined towards knowing what is their ppm level or what is their PM 2.5 and PM 10 level and CO2 levels in their rooms.
Sure, makes sense. Yeah. I think there are a couple of questions around how can redundancy be achieved using IoT and also around LoRa. So, and does Zenatix works on LoRa? If you allow, I can just
please. That is your. I tell my people that don't get into bits and bytes unless you are a bits and bytes person. Depend on the expert to answer that. So I leave it to you.
Sure. So I think I'll just touch upon it that, I mean, there were a couple of slides that Mr. Prabhat mentioned, talking about different wireless technologies, Wi-Fi, LoRa, and then OpenThread and Bluetooth 5.0 can be put together in a similar bucket. So one, redundancy is, because all these IoT systems are wireless, you try to maintain redundancy via multiple ways, right? The first is that, let's say your end device, which is actually controlling the equipment, sensing some value, which is either temperature or pressure, and then controlling some valve or some VFD speed, etc. That end device, even if it gets disconnected from the gateway that is installed in the zone or in the building, should still be able to function independently, right? So all the rules, all the PID logic should then reside on that end device. That is the first level of redundancy. Then the connectivity between the end device and the gateway, that has to be via a wireless technology, which should allow a multi-hop mesh and not a star network, because in a star network, you don't have that redundancy in the place, right? So essentially that wireless networking should support the second level of redundancy. Then the third level of redundancy comes in that if the gateway gets disconnected from the cloud, then the gateway should be able to maintain that zone or maintain that whole building in an independent manner, even if it gets disconnected from the cloud. So I think there are these three multiple level of redundancies. We have looked very, very closely into ensuring that these redundancies are put in place in the right manner, because the moment you get to control, I mean, it's a business critical operation, right? I mean, the whole building can come down if you're not operating the AHUs or the chillers properly. I think there is also a related question that some people comment that they have not seen the air handling units and chillers being together controlled on a single IoT platform. I mean, I would say that Zenatix has done that. We do both the low side control and the high side control. So separately, again, please reach out to us and we'll be happy to explain it in more detail, how they both can be handled together on a single platform. There is a comment, Mr. Prabhat, that there are several companies with IoT technologies, but adaptation rate by industry has been slow. Any thoughts? Would you like to comment
Yes,
on that?
yes. So it's only programs like this that we are doing today needs to go in to increase the adoption rate, because you need to spread the message. You know, uh, it's not, the bigger guys have not really done justice to the IoT technology. That's my gut feeling, because it sort of goes against their grain at this point of time. The smaller guys don't have the big budgets to do these kind of things. But what has come to our saving is things like these Zoom meetings and things like that, where we can repeatedly go out to people and enlighten them about what is possible. And it reminds me of a very small story, Amarjeet, and I will definitely tell it right now. There was this salesman sent into a remote place in Africa to sell shoes. And 1 week later, he said, nobody uses shoes over here. I'm coming back home. Okay. The next guy who was sent to the same market, he said, wow, this is one of the best markets that I have seen. Very few people use shoes. And if I can get a couple of people to wear shoes, everyone will start wearing shoes. So it's that is where we need to go. I'm to say, if we are able to get some good users and showcase what is being done with them, then you will see the adoption increasing at a very great pace. And the reason why people like me are interested in getting this adoption increased is because we are trying to solve another problem, which is basically global warming and effects of HVAC on the environment more than just the energy saving. Okay, and there are a whole lot of us who believe very firmly in that, and we need to kill the two birds with the same stone.
Sounds good. There is a comment on different certifications like IEC, UL, etc. I mean, we have necessary certifications for our hardware. There is also a comment around cyber security standards. I think many of us now appreciate the amount of security that is required. And I think many of these systems today follow several of those standards, right? I mean, the whole communication is happening over a VPN, over HTTPS. So it's pretty much as safe as doing your banking online.
Yeah.
Even within a local wireless mesh, people do secure communication. So you can you can sort of avoid many of the different cyber physical attacks. I think the world acknowledges the need for a secure communication and greater security, and many of the solution providers are already incorporating it. There's one last comment I would take upon that. I have seen some cheap sensors which directly connect to the electric mains and then give a dashboard where you can monitor the electricity consumption as a graph. Any comment? Mr. Prabhat, you want to mention?
No, I have not seen anything that is real. The best that I showed on my screens, let me just go back on this, is this Monet. You see it on the left-hand side? The three tongs for the three phases, and it goes directly to one particular thing, and it has got a antenna jutting out. Okay, and it talks directly instead of any particular accessories. But this is a one-off thing, and we are going more into systems-oriented things. Okay, so yes, all of us are enthusiasts. Things show up. I think we should have a bigger forum where we exchange these particular information. And if something is nice and reliable and can get into producing the same result over a period of time, we should be willing to adopt it. That's what my take is on it. We have to keep the cost under wraps. we will no longer call it cheap. We will call it cost effective.
Right. I think that's a good note to perhaps take this seminar to a conclusion. We have already exceeded 20 minutes and I still see 50 plus attendees being there. That clearly shows the interest this broader community has in this very, very important topic, right? That touches upon the realities, right? That the sustainable future, the sustainability, what we are passing on to the next generation. And I'm happy to see that many of us are serious about it. At Zenatix, we take these things very, very seriously. If you have any suggestions on what other topics you would like to hear from, and we are of course connected to different experts across the industry, both in India and globally, we'll be happy to get some of those experts like Mr. Prabhat onto these forums and organize many more such panel discussions and seminars. Do let us know if you have any thoughts on what else you want us to focus on in our future webinars. And with that, I would like to perhaps finish it up and thank you all the attendees. Thank you, Mr. Prabhat, for your time, also taking out a little bit of extra from your 1 hour schedule time. And we will definitely come back to all the attendees with the next session that we are coming forward to. Looking forward to getting you all back into the future seminars that we should be organizing.
Thank you very much.
Thank you all.
I would also like to thank everyone for taking the time out and participating. And keep sending your questions to Zenatix or to me, and we will make sure that we form a group later so that we can answer all your questions. Thank you.